Okay, good morning. Hope everyone is doing well today. So today's example is going to be example 4.4. So we'll finish this one today, and then examples 4.3 and 4.4 will be due next Tuesday, and then next week we'll do some preparation for the take-home exam, and that'll be next week. All right. So for today, let's open up the example 4.4 document. And you can also open up the blending oil Excel file. All right. So I'll read the description in a minute. This one shouldn't be as long as the last two exercises, and we haven't got to the solver table feature yet. I'd like to get to it today, and so if we have time, if we get to step 9, I'll walk us through the solver table. So assuming we have time, I think we'll do some features of the solver table, and I think there'll be some issues if you're using a Mac. And so all the solver table steps and things that we do will be basically optional. So if you can do them when I do them, then great. But if not, it's no big deal. So the solver table is kind of just an extension. Make some nice tables, and so I'll try to have time to show us that. But if you're unable to do it, then no big deal because it's optional. All right, so this is the exercise we're doing. So this is a blending problem. So Chandler Oil, some hypothetical oil company, has 5,000 barrels of crude oil 1 and 10,000 barrels of crude oil 2 available. And they're going to sell gasoline and heating oil by creating the product by blending some combinations of the two types of oil. So these products are produced by blending together the two crude oils. Each barrel of crude oil 1 has a quality level of 10, and each barrel of crude oil 2 has a quality level of 5. Gasoline must have an average quality level of at least 8. And heating oil must have an average quality level of at least 6. So gasoline sells for $25 a barrel, and heating oil sells for $20 a barrel. Let's assume that demand for heating oil and gasoline is unlimited, so we're going to sell the product no matter what. And all that Chainlink wants to do is all their production costs and be minimized. So Chainlink wants to maximize its revenue from selling gasoline and heating oil by developing a blending plan that we're going to do with this exercise. Okay, so let's start with this one, example 4.4, blending oil. The first thing we normally do is let's denote the light blue inputs, the decision variables, which are light red, the objective cell, which is yellow, highlight yellow, and then the constraints, we'll put an inequality in there. So let's start by doing that for step one, and we'll go through the model with the inputs and such. Okay, so the value per barrel and the quality level are set. So we know that initially, crude oil 1, it costs $65 a barrel, and crude oil 2 costs $50. So the prices in the older textbook are a little bit different, but it's the same idea. So here's the cost of each barrel of crude oil 1, and here's the average quality level, and the same for crude oil 2. So this little area, inputs, can highlight that, the light blue color. Okay, and also the selling price of gasoline is 75. The selling price of heating oil is 60. And the average quality has got to be at least 8 and 6 for those two respective products. So this little area is also an input range. You can color that light blue. Okay, we are going to decide the decision variable range. The decision variable range is actually this, how much crude oil 1 and 2 to use for both of the products. So that means that this range, B13 to C14 is actually the decision variable range. So you can select that and color that the light red color, because that's going to be what Solver chooses when we maximize the model. So this area is our decision variable range. So there's, this is like an older spreadsheet, so there looks like there is no red, so you can choose the light, like orange. Okay, and then how much crude oil 1 and crude oil 2 we have to start with, which are 5,000 and 10,000. Those are inputs. Those are set for now. Light blue. Okay, we need to note a constraint here because we can only use what we have available. So this is how much crude oil 1 we have. We can't use more than that. And this is how much crude oil 2 we have. We can't use more than that. So we'll denote that we have a constraint. Put a couple inequalities right here to show that we can't use more than we have available of each type of oil. So at E13 and E14, you can put the less than or equal to signs to note the constraint. All right, let's put our second constraint here, because it says quality constraints with clear denominators, so that means that we're going to tell the model that we have to meet the quality level for each of the types of product we sell. So the quality obtained has to meet the quality required for both types, and so you can put a greater than or equal to sign here. And there, so B20 and C20, put the greater than or equal to signs to denote the other constraint here. So this is the quality constraint. When we do the model, the quality we obtain has to meet the quality required in order to sell it. So put those signs there for the second constraint. Then B24, the total revenue, that's what we're going to maximize. That's the objective. We know we need to color that the light, or not the highlight yellow color. So this is our objective. B24, make that highlight yellow for the objective. Okay, so I think we're ready to start to go on to step 2. So we just highlight our inputs, decision variables, the objective, and then we put in the signs for the constraints. Alright, step 2 is just to make the range names. So you can go back to the spreadsheet and let's make some range names. Let's see here. So the first one we need to make is a manual selection. So we're going to make a full range name for the decision variable range. Okay, so if you select all the light orange cells or whatever color this is, B13 to C15. Alright, we're going to manually call that the blending plan up in the name box. Okay, so B13 to C14, just go up in the name box and call that blending underscore plan. Alright, and then hit enter. Okay, so that's blending plan. Let's make range names for the barrels sold and the used. So select A15 to C15 and then go to the Formulas tab. And then create some selection, then left column, hit OK. You can select used, which is D12 to D14, and make a range name for that. Formulas, create some selection. Top row, and then hit OK. We can do one for both available and leftover at the same time. So if you select F12 to G14, and then go to Formulas, create some selection. And it should do top row, so hit OK. Okay, and then we want one for this other constraint, the quality obtained and quality required. So you can do quality obtained and select A19 to C19, and then do formulas, create from selection. Left column, okay. Okay, do it for quality required, A21 to C21. Formulas, create from selection. And then left column, okay. Alright, and then finally the objectives, just select A24 to B24 and do the final formulas, create from selection. And then left column, okay. Okay, I'm going to hit the name manager, and we can confirm that we have all the range names set up. All right, so we got available, we got barrel sold, we got blending plan, we got leftover, we got quality obtained, we got quality required, and we got total revenue, we got used. So we got those range names set up. Does everyone have those range names? And make sure you got the blending plan, which is B13 to C14. So you have to manually do that. Okay, so we'll get on the range names, and we can go to step 3. Alright, step 3 is easy. We just gotta put any numbers into the decision variable range, the blending plan range. So back to the model. You can put any number, I'm gonna put ones in, so just all the orange cells, just put ones in there. Okay, so we put ones in that range, and solve is gonna find the optimal quantities later. So just put ones in there for now. Alright, step 4 is to calculate the sums for bears sold, the sums for used, and then leftover in the right column. So these, let's go back to the spreadsheet. Okay, so barrels sold is the sum of the two gasoline cells. So in B15, this is just equal to B13 plus B14, alright? And then you can drag that over to you can grab the bottom right corner of B15 and drag it over to C15 to get the sum for the heating oil column. Okay, then we need the sum for used, we just need the sum across the row. So in used, in D13, just equals B13 plus C13. Okay, to sum those two, hit enter. And we need the same for crude oil too, so just grab the bottom right corner of D13 and drag it down to D14. Okay, we need to calculate leftover in cell G13. So leftover is just how much is left over from the available given what we used. So in leftover, it's just available minus used. All right, that's obviously what's left over. So in G13 equals X13 minus G13. And just drag that down. So grab the bottom right corner of G13 and drag it down to G14. All right. So did we get all that for step 4? Okay. Let's go to the next step. All right. Let's calculate the quality achieved in cell B19. So step 5. Let's use the sum product in B19 to get the quality achieved. Okay, so in B19, you can put in this formula equals equals sum product, and in the parentheses B13 to B14, and then comma, $C, $4, colon, $C, $5. So the first, the B's have no dollar signs, the C's have dollar signs. So there's your formula, and you can see it's going to take the sum product of these two ranges, so it'll be this times this plus this times this. So it should give us 15 for now. Okay, and you can apply that over to the heating oil cell and just take the bottom right corner of B19 and drag it over to C19. Alright, so that moves it to the heating oil, but leaves the quality boxes the same. So it's this times this plus this times this. Again, for now it should be 15. Okay, the next step is to get the quality required. Step 6. Okay, do that B21. So back to the spreadsheet. In B21, here's your formula, equals B9 times B15. So the B9 cell is the required quality, 8. And this is how many barrels sold. So for now it should be 16. And you want to apply that to the heating oil cell. So just grab the bottom right corner of B21 and drag it to C21. Okay, so this one should be the heating oil quality times how many are sold for that. So for now, 6 times 2 should be 12. Okay, and we're gonna add a little section over here because the quality constraints are clear denominators. This makes it for the model to solve easier, but it's a little confusing why these are like 15s and 16s. And so to make it so when the model solves it makes more intuitive sense, we're going to make it so you also see the average quality. So the required quality is 8 and 6. Okay, and these are summing them together. So like instead of being the average quality, it's the total quality, like as a full product. But I think to see it as the average quality, where you know you have 8s for the gasoline and 6s for the heating oil, makes it more clear to see what's going on in the solver. So let's make a section over here, starting in E17. And let's just give this a title called, let's call this quality constraints in intuitive form. Okay, so quality constraints in intuitive form, we're just going to represent the quality constraints in a different way that's easier to visualize. All right, and then here in E18, let's title this gasoline. And then in F18, here it is, put the heating oil name here. This is heating oil. Okay, and we're going to put our constraints right here, and then we're going to get them so it displays the average. All right, so when the model is solved, you'll see that it should be the eights are the averages for the gasoline, and the 6s are the averages for the heating oil. Okay, so you can put in just greater than or equal to signs right here in E20 and F20. All right, and then all we're going to do here is we're going to divide all the numbers over in the clear denominator section by the number of barrels sold for each type, and then that will give us the average quality once this model is solved. So in E19, just type in equals E19 divided by B15. And then in this one, F19, this is equal to C19 divided by C15. Okay, so that'll give us the average, like average barrels sold, if you divide by the numbers sold. And then down here, let's get the averages as well. So in E21, this is equal to B21 divided by B15, so the average for the quality side, the quality required side. And then finally here, this is equal to C21 divided by C15. Okay, so all we're doing is dividing these numbers by the average, the total number of barrels sold. So these two over here should be divided by B15, and then these two over there should be divided by C15. So here's B19 divided by B15, C21 divided by B15, and then this one is C19 divided by C15, and then C21 divided by C15. So we just divided these numbers here by the number of barrels sold to get the average quality. Okay, do we get that extension there? Is everyone following along? All right. The next step is just to calculate the revenue. Okay, so revenue is, let's put the sum product into cell B24 for the objective. Okay, so in B24, here's your here's your formula. Okay, so the formula is equals sum product B15 to C15, comma B8 to C8, and then plus another sum product G13 to G14, comma B4 to B5. Now the reason we have two sum products is because this company has the option, if it doesn't use all the barrels in production in producing heating oil and gasoline, we can sell them at the wholesale price to recoup some of the revenue. So whatever isn't sold, whatever's left over, can be sold at the original price per barrel of these ones up here. Okay, so they want to sell gasoline and heating oil at these market prices, but if they're unable to do that, or if there's some left over, they can sell the leftover barrels back at 65 and 50 respectively. So that's why we have the double sum product for how much we sell of each for the market prices, and then how much is left over, we can sell that back at these prices. So see how it's equal sum product B15 to C15, comma B8 to C8. That's just, we sell this much gasoline to at $75, then that's the revenue. And then if we sell this much heating oil too at $60 each, that's the revenue for those two. And then if you have any left over, we can sell the leftover crude oil 1 at $65 a barrel, so this times this. And then we can sell the leftover crude oil 2 at $50 a barrel, so that's this times this. So there's four products that can possibly be sold. So that's why you have the sum product here for both options of the market prices and then the leftover wholesale prices. Alright, so this will change when we do the solver, but for now we should get $825,040. Alright, the next step is to solve the model, so to run solver. So step 8. we're going to use the solver feature again to maximize revenue subject to the constraints by choosing how much crude oil 1 and 2 to put into both of the two types of products we can possibly sell, and then any leftover can be sold at the wholesale price. Okay, so let's double check that everyone has Solver. So I've showed you how to activate Solver the last couple meetings, but if you don't have it now, I can show you again. So when you click on the Data tab, if you have Solver, you should see the Solver feature. So let me post the question again and see if anyone needs to reactivate Solver. Okay, so does anyone not have Solver? I can show you how to activate it, but let me know. So does anyone not have Solver? Okay, well, it seems like everyone has it, which you should because we've used it the last couple times. But if you do not, let me know and I'll show you how to reactivate it. So let's use Solver. Alright, so click on the Data tab, and then click on Solver to run Solver. Okay, so when you hit Data and Solver, it should take you to this Solver Parameters option. We've used this a couple times, so we need to specify the parameters, and then we'll tell Excel to solve it, and then we'll talk about the solution. Okay, so it still probably takes some getting used to, but hopefully you see what we're trying to do. So let's specify the objective. Click on this button. Okay, so the objective is D24. So just select that and then hit the button again. This is a maximize function, so we're trying to maximize total revenue, so leave that as max. Then by changing variable cells, hit this button, and let's manually choose the blending plan, which is that area. So if you choose D13 to C14, and then hit the button again to select it. Okay, and we have a couple constraints. Hit add to specify the first one. Okay, the first one is the resource constraint. We can't use more barrels than we have available. So cell reference, hit the button and select the used area. D13 to D14, and then hit the button to select it. And then the constraint is the available range, so hit the button and select F13 to F14. Okay, so it should say D13 to D14 is less than or equal to F13 to F14 for the appropriate resource constraint, and hit the OK button. All right, and then we got one more constraint, which is the quality constraint. So hit add again to add a second constraint. Hit this button to choose the cell reference. Which is B19 to C19. And then make sure you flip the sign around. So this has to be greater than or equal to, because we have to meet. We have to get at least the quality required. So switch the sign to greater than. And then the constraint, hit the button, is the quality required range. Which is B21 to C21. And then hit the button again to select it, and it should say you got B19 to C19 is greater than or equal to B21 to C21. And then hit OK. Okay, so before we solve it, let's go through and make sure your parameters look like this. So your objective should have defaulted to the range name, which is total revenue. You're going to maximize that. By changing variable cells, that should go to the range name, which is blending plan. And you have two constraints. Quality obtained is greater than or equal to quality required, and use is less than or equal to available. And then make sure that this box is checked if it's not, and make sure your solving method is simplex LT. So look at your solver parameters before we solve it, and if you have anything that's different than this, then let me know and I will help you fix it. Okay, so everyone has this these solver parameters specified. We can solve it. All right, let's hit the solve button and see what we get. Okay, so hopefully it says solver found a solution, and just hit the OK button to see the solution. And I think, yeah, you should get 975,000 for your maximum total revenue. Is that what? Can we get that? Okay, and so what happened is we used this much barrel, these many barrels of crude oil 1 and 2 for both of the heating oil types. And we sold this many of each type of gasoline and heating oil at $75 and $60 respectively. I don't think we had any left over. Let's see. No, we don't have any left over, so we don't have to worry about that. And you can see that the quality constraints should have come out like this. So if you did the quality constraints in intuitive form, hopefully you see that the average quality level 8 is greater than or equal to 8 over here. So that makes more sense. And then this should say 6 is greater than or equal to 6. And you can see that we used all of the available barrels of both types, and we exactly met the quality constraints. So all the constraints are binding, and hopefully we got 975,000. So everybody got this solution? Okay, well, it looks like everybody's on track so far. So now we're going to use I'm going to show you guys a feature called Solver Table in the next step, step 9. Okay, so we're going to use Solver Table. My guess is that there's going to be some issues using it, especially on Macs, and that's okay because these next steps are not required. They're optional, but if you can follow along, then that'd be great. So we're going to use Solver Table. I'll show you how to load the Solver Table and activate it. And if Solver Table doesn't work, typically there's problems on Macs because I'm not sure if the version is Mac friendly. Then that's okay. Steps 9 through 10 are not required. So I have on Blackboard the Solver Table like add-in feature, and I'm pretty sure it's for Windows. So I know there's a Solver Table feature for Mac, and so if anyone can find the Solver Table feature for Mac, and you don't have to do it right now, but if someone's good at Macs and not finding software add-ins, then maybe we can get the people that have a Mac to get Solver at a later date. But let me show you right now how to do the Windows Solver. Alright, so I put the Solver, we were projected to use it in the example 3.1, but we didn't have time for it the last couple times. So on Blackboard, click on example 3.1, and you should see the solvertable.xlan thing. Okay, on Blackboard. And if you're if you're following along here, just click on that to download it. So download it, but don't open it because you have to open it through the exercise. So just if you're following along here, go to example 3.1, click on the Solver Table feature or add-in to download it, and just leave it there. All right, and then go back to the model, the spreadsheet. Okay, and then here's how you will load or activate Solver Table. So click on the File tab, and then click on Options. And then when you get here, click on Add-ins. And then down here where it says Manage Excel Add-ins, click on the Go button. Okay, and once you're here, click on the Browse button. See it says Browse. And then what you got to do here is choose the file you just downloaded, which is most likely in your downloads, or wherever your default downloads go. So see how I want to choose the solver table file I just downloaded. Okay, so if I go to downloads, there it is. That's the one I just downloaded. So just find it where you downloaded it and select it and hit OK. And then hopefully, if we're able to get this far, it's going to show it up. It's going to show it in this add-ins table, or the add-ins available. And so if that worked, just select the solver table and check it. Right? See how there's a bunch of them here, but they're the same thing. So the solver table you just found, click it and hit OK. And then if that worked, you'll see how it's a tab. So like up here there's like Home tab, Insert tab. If that worked, you have the solver table tab here, which we're going to use for the solver table. So my guess is that that didn't work for everyone, but were some people able to get the solver table? Okay. Does anyone need me to do the steps again? Okay. So let's do the steps again. And so go back. So here's what we started with: is just go back to the Blackboard page. Okay, and then go to the example 3.1 section. All right, and then see the solver table .xlam option. Just click on that, and it'll download it, or just download it. Okay, so it's now downloaded, hopefully. Okay, then go back here to the model we're working on, the blending RL model, and then here we go, File tab, and then Options, and then Add-ins, and then down there where it says Manage Excel Add-ins, click on the Go button. Okay, and when you get to this point, hit the Browse button, Browse, and what you got to do here is choose the file you just downloaded. So wherever that solver table file was downloaded, select it manually. It's probably in your downloads, unless your downloads go somewhere else specific. Okay, so there it is. Solver table, select it, and hit OK. All right, and then the solver table feature, there's a bunch of them here, but they're all the same thing. So this is the most recent one. So if you're able to download it, find it, and check it, then it should be here. So check the solver table, and like that, and hit OK. And if that works, it should be up here in the right. You should see a solver table tab. Okay, so Kayla, did that work? Or solver table? Okay, you're welcome. And all right, so hopefully that worked for some of us. And let's try to use solver table. So again, if this doesn't work or you weren't able to get solver table, the steps of the solver table are not required; they're optional, but they're kind of fun if you're able to do it. And so let's try running solver table. So click on the solver table tab. Okay, and then hit run solver table. And then hit OK, or hit yes. And let's do a two-way table. All right, so hit choose two-way table and hit OK. Okay, and if this is working, it should take you to this parameters for the two-way table. And here we're going to specify the parameters and get the table we're looking for. So hopefully this worked for some of us. Let's specify the inputs. Okay, so what we're doing here is we're going to create a table showing if the prices of crude oil go up or down, what happens to the objective and the decision variables. So input 1 is going to be B4, so you can hit this button. And just manually choose B4, right, and then hit the button again to select it. The other input is going to be B5. Okay, and the description, this is the crude oil 1 price. And this one is the crude oil 2 price. Okay, and we're going to make it, we're going to change the prices to be above and below what the current or the default is. So the price of crude oil 1 is $65 right now. So let's make it maybe go from 50 to 75. All right, so we can try minimum value 50 and maximum value 75 in increments of 5. And the current crude oil 2 price is 50. So let's maybe make this one go from 40 to 60 in increments of 5. Okay, and then what we have to do is select the output cells. So you got to hit this button. And we're going to select the barrel sold range, the leftover range, and then the objective, which is revenue. So you got to do this. So first, let's select the barrel sold range. B15 to C15. Then you got to hit the control. You got to hit a comma, and then you have to hold down the control button while you make the other selections, or else it's going to mess it up. So hold down control. And while you're holding down control, select G13 to G14. Okay, see how it comes after the comma? There's a second selection. And then hit a comma again. And then hold down control and hit, and choose D24. Alright, and then hit the button here to select it. Alright, so there's a lot going on here, but this is what the parameter should look like if you're able to do this. So input cell 1 is B4, input cell 2 is B5, and don't worry about the dollar signs or the model thing, just worry about the selections. So this is the crude oil 1 price, and this is the crude oil 2 price. This one's going to increase, go from 50 to 75 in increments of 5. And this one is going to go from 40 to 60 in increments of 5, and these are the output cells. There's 3 ranges, B15 to C15, G13 to G14, and then D24. So you selected all the 4 things you can possibly sell, and then also the revenue. Okay, so next I'm just going to hit OK to get the solver table. So does anyone need me to do any of this again in the solver parameters? Are we in the solver table parameters? All right, let's try hitting OK and see if this works. All right, so if you got this far, you should get a separate tab. See, it says like STS_1 for the solver table, and it creates tables for what you specified. So we told it to make tables changing the selling price of the 2 types of crude oil and how that affects what we sell of each type and also our revenue. So if you're able to see this, this is what happens when, so the top values are crude oil 2, and then the side values are crude oil 1. Right, so this is what's happening to the price of crude oil 2, and then this is what's happening to the price of crude oil 1. And the point here is to see that there's like a turning point or a marginal effect where if the price gets high enough for the wholesale price, then the company realizes that and just sells it at the wholesale price because it's more valuable than blending it into the oil or the gasoline. So see if what is this? This is barrel 1 sold. So this is barrel 2. So if the selling price of crude oil 2 gets up to 55, then we stop using it to make heating oil. Okay, and the same here. If the price gets up high enough for Yeah, so I think the best thing to do would be just to verify one of these findings by doing it in the model. And so it's kind of hard to see everything going on, but we're trying to find the point at which the heating oil price, the crude oil prices get high enough where you just sell them individually, you don't use them in the final product. So if I look here and say, all right, so if the price of the price of crude oil 2 goes to 55, and the price of the crude oil 1 goes to is 50, then we're going to sell a bunch of leftovers, and we're not going to use it in the final product. So you should get this result in the model. So let me just show you what I mean. If you go back and change the crude oil 2 price to 55, you don't have to do this, but I'm just trying to explain what happened in the table. So if I change the crude oil 2 price to 55 and then rerun the model, okay, so see what happens. So the solver table said that we would sell this much of the leftovers. All right, and we did. So see how the table makes sense? So if the price of crude oil 2 got high enough, in this case 55, then we start selling crude oil 2 because it's more valuable than using it for heating oil. So if these are the prices, then the way to maximize revenue was instead, let's only sell gasoline, and also let's sell the rest at crude oil 2. So if the price of crude oil 2 gets high enough, and the company doesn't use it for heating oil, instead it uses some for gasoline and sells the rest at the wholesale price. So this is saying that if, like the price of an input gets more valuable, you can alternatively sell that just at the wholesale price and not even use it in the production process. Okay, so hopefully that makes sense. I'm going to change it back to the original, so it looks like it matches even numbers. Okay, so the original values were 65 and 50, and if you did the change like I did, you can just, if you want, you can just change it back and rerun the solver, and then it gives us to the original solution where we had 975,000. All right, so I'm sure that everyone was not able to do the solver table, but hopefully it makes sense of what we're trying to do here. So did Dominic or Taylor, were you able to get the solver table to work? Oh, great. Okay. Okay, good. So, yeah, it takes a while to get it loaded, and it's kind of complicated specifying the parameters, but it's pretty useful because you can find out kind of what the tipping point is for some of these models. So, if you tried to get the solver table to work and it didn't work, then let me know and I can try to help you fix it. If you tried to use it on a Mac, most likely it didn't work because I think it's for Windows. But you can get the solver table feature for Mac. So if anyone's, smart like that and able to figure out how to get the solver table for Mac, then let me know and I'll try to share it to the rest of the Mac users next time or going forward. But all the solver table features they're not required. You don't have to do it, but it is a nice feature if you can. All right, so we're done with the spreadsheet part. So the model where you got the 975,000. Okay, so save that. That's what you turn in for example 4.4. So that goes into the discussion forum. If you have the solver table, just leave it there. If not, don't worry about it. You're not going to. The solver table is optional. Okay, so example 4.4 goes into this discussion forum, and that's due next Tuesday. And let me just go through the practice problem for this exercise. So let's go back to example 4.4. Okay, so just to clarify, so for example 4.4, you only have to do steps 1 through 9 to get credit. Sorry, steps 1 through 8. Steps 1 through 8. Okay, so up to just running the solver. So the solver table for step 9, if you got that great, we didn't get to this, we didn't get to this. So just steps 1 through 8 are what you need to do to turn in example 4.4. Okay, so there's a practice question at the bottom of example 4.4. Let's go through my solutions for that. If you go to example 4.4 on Blackboard and open up the example 4.4 practice question solved. All right, so here we go. We have a printout that's similar. It's the same model, but the values are a little bit different. So you got the crude oil 2 and crude oil 1, and then the optional. You can also sell the gasoline and heating oil. So step part A, given the current parameters, calculate the objective. So what would your revenue be given this screen cap of the model? Okay, so remember you have 4 things you can possibly sell. The leftover barrels and the barrels sold. So the leftovers and the barrels sold of each. There you can see that no leftovers sold. The only thing to sell are 15,000 of this at $100, and then 4,000 of this at $75. So the total revenue from those 2 types is the revenue. All right, so 100 barrels of crude oil. $100 for gasoline. We sold 15,000 barrels, and then $75 for heating oil, and we sold 5,000 barrels. So if you do this together, you get a nice total revenue of $1,875,000. All right, and then part B, let's identify the constraints as either binding or non-binding. Okay, and so the constraints we have the resource constraints, and we have the quality constraints. So we have this one where we can't use more crude oil 1 than we have available, and we have this one where we can't use more crude oil 2 than we have available, and we have these ones where the quality obtained for gasoline has to be at least the quality required, and the quality obtained for heating oil has to be at least the quality required. So we'll specify those three, and you can notice that we use all of the available for both types, so those are binding, and we exactly met the quality constraints, so those are binding as well. All right, so the constraints are crude oil 1 is going to be less than or equal to the crude oil 1 available, binding no slack. The same for crude oil 2. Crude oil 2 used has to be less than or equal to crude oil 2 available, and we use all of that, so that's binding no slack. And then the resource quality constraints, the quality obtained for gasoline has to be greater than or equal to the quality required for gasoline. All right, that was met, binding no slack, and then the quality obtained for heating oil has to be greater than or equal to the quality required for heating oil, and that was also binding with no slack. All right, then part C, finally. Let's interpret the shadow prices only for the resource constraints in D13 to F14. So if you look at the sensitivity report, so don't worry about the ones that have like negative 12.5. Those don't have intuitive interpretations, but you can interpret these two. So for the crude oil 1, the shadow price is 65, and for crude oil 2, the shadow price is 12.5. And you can see that initially we've used all of our crude oil 1 and all of our crude oil 2. So these shadow prices are the exact value of one more barrel, and so you can specify that given the shadow prices. So what this means is for crude oil 1, the shadow price, the value is 65. So if the firm gets one more barrel of crude oil 1 and uses it, then total revenue is going to increase by $65. So the value of one more barrel is exactly 65. And for the crude oil 2, it's a little less valuable, but it's 12.5. So that's the value of one more barrel of crude oil 2. So if the firm gets one more barrel of crude oil 2 and uses it, then the total revenue will increase by $12.50. So again, the shadow prices are the exact value of getting one more of the constraint. In this case, it's one more barrel of each of the types of 1 and 2. So the crude oil 1 barrels are worth $65, and crude oil 2 barrels are worth $12.50. Okay, so questions on this? We practice problems here for what we did with the objective, listing the constraints, and interpreting the shadow prices, which is one of the important things. All right, so let's just sum up here, and then we'll finish up for the day. Okay, so example 2.6 and 3.1 were due on Tuesday. I'll get those grades up later this weekend. Then example 4.3 and 4.4 are due next Tuesday. Okay, so get those in the Blackboard form there. Okay, so we finished the material for the first third of the class. So that means that next week next Tuesday we'll start doing some review and practice problems for what is going to be on the take-home exam, and then I'll post the take-home exam probably Tuesday, and then so I know Tuesday for sure we're going to do a review for the exam, and then Thursday we can either do more practice problems or I can just have office hours. So we'll see that. So the midterm review is Tuesday, and then Thursday is either going to be more review or I can just have office hours if everyone is good for the midterm. Okay, so I think yeah. Okay, so I think that's it for today. I'll see everyone. You will post the review on Tuesday. You mean I'll post I'll post some practice problems or practice exam by Tuesday, and then we'll go over it in class on Tuesday, and then at the end of class I'll post the actual exam that you have to do via take home. Yeah. So Tuesday we'll have a practice exam and some practice problems we can go through, and then after class on Tuesday, I'll post your midterm. Okay. All right. So I think that's it.
Do we have class on Thursday? Next Thursday? No.
Well, I don't. It depends. It's gonna like if we get through everything on Tuesday for the exam and everyone feels good about the exam, then I'll just have office hours on Thursday, and if you have questions on the exam, I can help you. But no, I don't have anything planned for Thursday. So
okay, thank you.
It's gonna be like a flexible option where I'll be here if you have questions for the exam or just office hours or anything else. But no, if you've done all the exercises and you're prepared for the exam, then Thursday is just office hours. Yeah. Okay, so I will see everyone next Tuesday for the review. And then you'll get your midterm 1 take home. And yeah, okay, so that's it for today. Everyone have a good weekend. And thanks for joining. And let me know if you have any questions.
Thank you.
Thank you.